For us, a lot of what we're going to be doing is in chapter 1 here is using those ratios to find out unknown values, right? And we're going to use some of those proportional relationships that we'll talk about, which are just equivalent ratios. And again, when you set it up like a fraction, like we have right here, that's something that we've seen before and we've reduced fractions before. So a lot of these answers are going to be looked at in simplified form or whatever you want to call it, lowest terms. So what that means is we're going to have to reduce it down, divide your top and your bottom, your first and your second number by a common factor to be able to put it in simplest form. So they're going to look at a lot of that, and then we're going to use these ratios to find some unknown values. So that's really where we're going with this. Hopefully you've seen it before, but if you haven't, I mean, there's other videos online. I'm going to put some more stuff up for you, but that's your initial ratios. Now, one thing they talk about right here, which is the unit rate, okay? A unit rate is a special type of rate, which is basically simplified down to where your denominator is 1. A unit rate will always have a denominator, which again, if you don't know what a denominator is, the bottom number will always be 1. So much of this for every one of that. That is a unit rate. Now, it's very simple to get your denominator to 1. All you have to do is divide. So if they said there are 6 cookies in 2 boxes, and you want to know, well, how many cookies is there per box, right? Per means divide. Per means divide. Fraction bar means divide, okay? So all you got to do is divide your top by your bottom. Anytime you want a unit rate, that's all it takes, divide, okay? So you take 6 divided by 2, and we know that we have 3 cookies per box. All right, so there is 3 cookies in each box. Now, the next part of this is go, okay, well, if there's 6 cookies in 2 boxes and they want to know something like, all right, well, how many cookies are going to be in 4 boxes? Well, you set it up. You got an equivalent ratio. 6 is to 2 as something is to 4, right? And that's the unknown amount of cookies that we have right here. There's a couple ways to do that, and I'll show you that as we go along. But you should know that go across 2 to 4 times 2, do the same thing to the top. You know that there are 12 cookies in 4 boxes. There's 3 cookies in each box. Let's see if that makes sense. 3 times the 4 equals a total of 12 cookies in 4 boxes. So that's something you can do with your ratios and your unit rates is to make some different calculations and project out those same totals using those same ratios. So anyways, that's kind of where we're going. Let's look at some of this, and I talked about the reducing of fractions. And the similarities that we have with ratios and fractions. It's the same thing, right? It's the same thing. But for those of us that need a refresher on reducing fractions, now, when you divide out a common factor, common means the same. Factor is a number that goes in evenly. So what you're looking for is between your numerator, top number, and denominator, your bottom number, a number that is evenly divisible by both. Otherwise, it's in simplest terms. So that's where you want it to be. If it's already there, great. If not, divide it down, reduce it down, and then we're going to use that in our other calculations. So let's look at number 1 here. Number 1, we got 20 25ths. A couple things to remember when you are reducing fractions. If it ends in a 0, 2, 4, 6, or 8 even numbers, are always divisible by 2. If it ends in a 0 or a 5, 0 or 5, you know it's at least divisible by 5. If it ends in zeros, you know they're at least divisible by 10. A couple other rules. I know with 3s, if you add up the digits and that number is divisible by 3, then the total number is going to be divisible by 3. So there's just a couple of the quick rules. So either way, let's take a look. 20, 25ths. Again, these are both divisible by 5, right? Ends in 5 and a 0. So your fraction, when you simplify, 20 divided by 5 is 4, and 25 divided by 5 is 5. So 4/5 is equivalent, again, it's equal to 20 25ths. And just like with ratios, these have the same equivalent equal value. The value is the same, just the number of pieces that changes. Okay, the value is the same. 4 out of 5 is the same as 20 out of 25, right? Those are equivalent in value. We make 4 out of 5 free throws, and somebody else makes 20 out of 25 free throws. You guys made the same exact percentage of free throws. All right, let's look at number 2. 27, 36. Now, hopefully, we remember our nines. Our nines, again, if you add up the 2 digits, they should be a number that's divisible by 9. And that's the case here, right? 2 plus 7 is 9, 3 plus 6 is 9. I know both those are divisible by 9. 27 divided by 9 is 3, and 36 divisible by 9 is 4. Now, even if you divide it and reduce it down, take a second look. See if you can go even lower, because you might have divided by a common factor, but maybe not the greatest common factor. So always take a second look and say, okay, can I reduce 3/4? We can't. That's in simplest terms, so we are good to go. Like with that situation, though, you could have divided by 3 and gotten 9/12, but 9/12 you can divide by 3 again. We divide by 3 on top and bottom, and you get 3/4. All right. Just look at this one, and then we'll move on. 12/28. I know they're both divisible by 4, but again, you could start by dividing by 2. If you don't know that they're both divisible by 4, you could divide by 2 and then divide by 2 again, because when you divide by 2 twice, it's the same thing as dividing by 4. But 13 divided by 4 gives us 3, and 28 divided by 4 is 7. So your answer here is 3/7. All right. Let's just put it on here.